This is a survey of calculus review, and the calculator I'm going to be using is this Casio 115 ES Plus. It has a pretty good button. It's got this calculus button here. If I hit shift, what that'll do, and then I hit that button, it'll take the derivative of a function at a point. And that's pretty useful in this particular class. So what I'm asked to do is find a couple of slopes between points on the graph and another point on the graph. So the first one says find the average rate of change from 1994 to 2000. So I go over here to 1994, which is at 0. And then I go over to 2000, which is, if I'm careful here, I can figure out is 18. So all that's going to do is give me from, I have two coordinates. I have 1994, comma, 0. And I have another coordinate, 2000, comma, and we found that out to be, I believe, 18. And average rate of change is the slope between those 2 points. So all I'm going to do is the slope formula between those 2 points. And I'm going to do y sub 2 minus y sub 1, 18 minus 0 over 2000 minus 1994. And that's going to give me 18 over, I believe, 6. So the average rate of change is going to be 3. So that's all it's asking for the first part there, 3% per year. Next one, it wants the average rate of change from the year 2000 to 2006. So let's see what that is. So from the year 2000, again, we already know that that's 18, to 2006. 2006 is going to land me up here. And let's see what y value that is. That's 1 below 25, so that's going to be 24. And again, that's going to give me two coordinates. One of which is 2000, comma 18. We already had that one. 2000, comma 18. And the other coordinate is 2006, comma 24. And the average rate of change, all it is finding the slope between those two coordinates. So I'm going to set up my slope formula. I'm going to do 24 minus 18. And I'm going to do 2006 minus 2000. And that's going to give me 6 divided by 6, which equals 1. So the average rate of change from 2000 to 2006 was 1%. Now they want me to do it from 1994 to 2006. Let's recall 1994 was at 0. So our two coordinates are going to be 1994, comma 0, 2006, comma 24. 1994, comma 0, 2006, comma 24. Find the slope between those 2 points. Use the slope formula. It's going to be 24 minus 0 over 2006 minus 1994. And what's nice about this calculator, it'll accept these fractions pretty nicely. I hit the fraction button. If you're bad with the arithmetic, you can just type that in like it looks. 24 minus 0, and then 2006 minus 1994. And it'll give me the slope is 2. For this particular problem, it's going to be 2%. We have another average rate of change problem. This time it's from 92 to 95. So at 1992, we notice the coordinate is going to be 1992, 8.5. And 1995 is right here. It's not shown, but that's going to be 7.7 million. So we want to find the average rate of change or the slope between those 2 points. And let's take a look. Our first point is 1992, comma 8.5. 1992, comma 8.5 million. Our other coordinate is going to be 1995, comma 7.7. And notice it's going down, so my answer should be negative. It's a negative slope between those 2 points. So I'm going to set up my slope formula. I'm going to do 7.7 minus 8.5 over 1995 minus 1992. I'm going to hit my fraction button. I'm going to type it in like it looks. 7.7 minus 8.5 over 95 minus 92, 1995 minus 1992, gives me a nice fraction, but we want that as a decimal, so we hit this button called the SD button, standard decimal. It's right over the orange button, so I hit that SD button, and it'll change it to a decimal. Negative 0.26 rep per 10. And if I round the 3 places, that's going to be negative 2.66 rep per 10. Average rate of change from 95 to 2000. So the bottom part is going to be 2000 minus 1995. The top part, let's see, at the year 2000, it's 9.8 million. At the year 1995, we already knew that one was 7.7 million. Notice, that's going to be positive slope. Going from there to there, I'm going uphill, so it should be a positive number. Going to use the calculator and type that in just like it looks. Hit my fraction bar. Type in my 9.8 minus 7.7. Down arrow, 2000 minus 1995. I know that's going to be 5, but I'm going to let the calculator do all the heavy work. So that gives me 21 over 50. But we're going to want to SD that and get the decimal of 0.42. Notice that's a positive number. Average rate of change from 1992 to 1998. So again, slope formula. The bottom is going to be 1998 minus 1992. 1998 minus 1992. And the value at 98 is 8.6. The value at 1998 is 8.6. So I put that 8.6 right above the 1998. The value at 1992 is 8.5. I'm going to do this one in my head. That's going to give me 0.1 over 98 minus 92, 6. I'm not going to do that in my head. 1/60th, and then I hit SD, 0.016666, 0.01666 repetition. 0.01666. So I have to round it to 3 places, so it's going to be 0.017. So for number 3, I have this really complicated quadratic, 0.03 x squared, 0.58 x, 9.95. And then for part A and B, they want me to plug in a 3 into that equation, and they want me to plug in a 13 into that equation. Then they want me to minus those values. Then they want me to find the average rate of change. Notice it's in the slope formula now. Once they have it that method, that's the slope formula. So they want me to find the average rate of change, or the slope between those 2 points on that curve. I'm going to use the Casio mode 7. So I'm going to hit mode, and then notice number 7 says table. So I'm going to hit 7, and instead of it showing P of x, it shows F of x. Well, I'm going to act like it's P of x. So I'm going to type that in just like it looks. 0.003. Now to get the x to appear, you got to hit alpha. Got to hit alpha, and then this little red x down here. See the little red x above the parenthesis? Red x. Then I have to square it. There's an x squared button right there. And now I'm going to continue with it. Plus 0.58x plus 0.58 alpha red x. It's got to be the x, not the times button. Plus 9.95. I don't need a g of x, so I just hit equals to skip that. If I hit equals, it'll just skip to the next part. Now, where do I want to start? Well, the low number is 3, and the high number is 13. So I'm going to start at 3, and I'm going to end. I hit equals, and I'm going to end at 13. And I know those are 10 away, so I'm going to step by 10, not 1. I'm going to step by 10. And that's going to give me the values. That's P of 3 equals 11.96. P of 13 equals 22.56. And that's going to give me my, my coordinates for the slope. So let's see. For my answer, for find P of 3, notice I already have it here. P of 3 is 11.96. We have P of 13. P of 13 is 22.56. Now they want me to subtract those. So I have to hit mode 1 to get back into normal computational mode. Mode 1, that means computation. So I'm going to do that. 22.56 minus 11.96. 22.56, not go with the decimals. Minus 11.96. 53 over 5. Hit SD. 10.6. Now they want me to do the average rate of change. Now they want me to do the average rate of change, which is just the slope. So I'm going to do the slope formula. So P of 13 was 22.56 minus P of 3, which was 11.96, over 13 minus 3. I'm going to write it out. And this sort of gives me the A-Rock formula. See how the 13 is in the front? It goes up in that little parentheses. The 3 is in the back. It goes in that parentheses. Now I'm going to enter this into the calculator. All I have to really do is divide this by 10, and that should give me the answer, 1.06. And I'm going to show you that it works if you type the original in the way they want you to. So 22.56 minus 11.96. Down arrow, 13 minus 3. SD it, and my answer is 1.06. That's my average rate of change. Now, I'm not good at reading. I don't know how to interpret this answer. Let's see. The result tells us that the price of it is more. No. I'm looking for something that says average rate of change. I have the word average. But that's not what I'm looking for. I'm looking for the word average rate of change. That's the key words that I'm looking for. So this should be choice D. Now we're going to find derivatives. Derivative of a number, the derivative of a polynomial, the derivative of a fraction, and the derivative of a radical and a fraction. So for number 4, it asks me to find the slope, or the derivative of y equals negative 3. And the best way for me to explain that is when they ask for derivative dy dx, that's the change in y over the change in x, or the slope. So they're basically asking me what's the slope of this horizontal line, y equals negative 3. So the slope of that horizontal line, if I use Hoy from the memory mnemonic Vox Hoy, if it's a vertical line, it would be an x equals a number. Its slope would be undefined, and it would be like x equals 5, and that means you'll go over 1, 2, 3, 4, 5 and draw a vertical line. And Hoy is the horizontal component of this note. Notice, the O from Hoy stands for that the slope is equal to 0. So the derivative of y equals negative 3, dy dx is going to equal 0. The derivative of any number without a letter behind it, the derivative of any number is 0. So I found the derivative of y, dy dx equals 6x squared minus 26x plus 48. Now I want to explain how I arrive at that. So another way to say you're taking the derivative of y is to write y prime. These two basically mean the same thing. This one is just quicker to write. So how I got the 6, I did something called the power rule. I did the exponent times the number out front. So 3 times 2, that gives me 6x. And then to get the 2, I subtract 1 from this exponent. So 3 minus 1 gives me 2. Notice I get 6x squared. I'm going to do the power rule for this term. So 2 times negative 13, that gives me negative 26x. But then I subtract 1 from that exponent, and that gives me a 1. But notice I didn't need to write the 1. 48x to the first, that's technically a 1 there. I do the power rule, 1 times 48 gives me plus 48. X to what power? When I subtract 1, that gives me x to the 0. And I hope we all remember that x to the 0 equals 1. So 48 times 1 equals 48. And now, the derivative of any constant is 0. So, my simplified version is 6x squared minus 26x plus 48. So now I'm asked to find the derivative of 60 over x to the 7th. There's a thing called the quotient rule, but there's a shorter way if it's not a complicated fraction. This fraction isn't that complicated, so what I did is I rewrote it. I brought the x to the 7th up, and when I did, that gave me a negative exponent. And now I'm going to do the general power rule. So to find the derivative, dy dx, or y prime, we could write y prime, equals, and I'm going to do negative 7 times 60, which I believe is negative 420, x, and I have to come up here and subtract 1 from negative 7, and that's going to give me negative 8. So that's my derivative for 60 over x to the 7th. So this notation means that I want to find the derivative of these items in the parentheses. So what I had to do was rewrite the fifth root of x. That's technically the fifth root of x to the first. I have to write it as what's called rational or fraction exponent. Now, once I have the fraction as the exponent, I can do the power rule. And I also took this 6 over x to the first and brought that x to the first up and made it a negative 1. It doesn't change this sign until I actually take the derivative. So I'm going to take the derivative of both of these terms. So the derivative of x to the 1/5, I do the power rule, I do 1/5 times the number out front, which is technically a 1, so that's going to give me 1/5 x. Now this is a little tricky, I have to subtract 1, but instead of putting a 1 there, I'm going to put 1 is 5 divided by 5. That's going to give me 1 minus 5 is negative 4/5. So that's the derivative of the front term. Now the derivative of the back term, negative 1 times negative 6, that's going to give me positive 6x. Come up here, subtract 1 from negative 1, and that's going to give me to the negative 2 power. So that's the derivative of a radical function and a fraction. Now number 8, they want me to find the derivative and then plug in 1. So the derivative, f prime of x, again, another way to write derivative notation is to put f prime of x, not f to the first, that's f prime. So I'm going to take the derivative, that's going to be 6x minus 5. And now they want me to plug in x equals 1. So I'm going to plug in the value x equals 1. So notice when I plug the 1 into the derivative, that's going to give me 6 times 1 minus 5. 6 times 1 minus 5. And that should just equal 1. Now, there's a way to do this on the calculator. And it's pretty useful. Not necessarily for this problem, but for if the problem were a little bit more involved. So what I'm going to do is I'm going to hit second, and then this button, and that puts me in ddx mode. So I'm going to take the derivative, and notice it gives me that notation that I'm going to take the derivative at x equals some value. So I'm going to type in 3 alpha red x squared minus 5 alpha red x plus 6, and I'm going to evaluate it at x equals 1, and I hit equals, and bingo. It gives me the slope at that point. So when x equals 1, the slope equals 1. Pretty nice. Now this is involved. We want to get used to when it says find the equation for the line that is tangent. When it says that, what you might want to think is this formula from Algebra 1. When it says find an equation or equation building line, is going to be y minus y sub 1 equals m, which is the derivative, times x minus x sub 1. We're going to be using that formula quite often. So, I have the equation 2x cubed, and I have a point, 2, 0. So I'm going to take the derivative of this equation, plug in the x value 2, and then I'm going to use this formula to find the equation of the line. Here we go. Y prime equals 6x squared minus 8, evaluated at the x value 2. So I take that 2 and plug it in. So 6 times 2 squared minus 8 is 24 minus 8. 16. What that means is the slope, the derivative of the slope equals 16. Now, I could have done this using the calculator. And here's how I would have done it using the calculator. Once again, I'm going to hit shift and then the derivative button. I'm going to type in that equation, 2x cubed, 2 alpha red x. Now I have to hit the Xbox button to get to the third power. Right arrow to bring it down. Minus 8 alpha red x, evaluated at x equals 2. Notice, this will give me the slope rapidly. And my slope is 16. So, I have a point, 2, 0. I have a slope, 16. And I want to find the equation for the line that touches that point whose slope is 16. So I'm going to use this equation. Y minus y sub 1 equals m times x minus x sub 1. Now, for this particular problem, my 2 is going to be my x sub 1. My y sub 1 is going to be 0. So that's going to give me y minus 0 equals my slope or derivative, 16 times x. X comes down, minus that x sub 1 value 2. If we want to freshen up our equation, we can simplify it a little bit. We could rewrite it as y equals 16 times x minus 2. Some people prefer to distribute the 16 and rewrite it as y equals 16x minus 32. Either one will be accepted by the computer.